It's not easy for us busy geotechnical engineers to keep up with industry trends while keeping up with our engineering work. Therefore, it's our goal at the Geotechnical Engineering Podcast to help you do just that. We strive to keep our listeners informed on important industry topics and also to educate you on interesting technical topics and trends in the geotechnical world. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Ben Haugen, the Director of Business Development for Remote Sensing at Geostabilization International, GSI, about geohazard monitoring and mitigation. I'm your host, Jared Green, and I'm excited to be bringing you yet another episode of the Geotechnical Engineering Podcast. And with that, let's jump right into today's episode.
This video is brought to you by Menard USA. Menard USA is a specialty ground improvement contractor that works nationally providing design-build ground improvement solutions at sites with problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard USA or for help on your next project, please visit www.menardusa.com.
Welcome to the show, Ben. How are you doing? Good to have
Doing
you on.
Great. Likewise, thanks.
Excellent. Well, it'd be great if you could tell our listeners a little bit more about yourself and what is it that you do on a daily basis?
Sure. So I'm a geological engineer. I actually have an undergrad degree in geology and a master's in geological engineering. And for the last 10 years or so, I've been involved in geohazard asset management, monitoring, and mitigation. I work for a company called GeoStabilization International, and the short for that is GSI. And we basically do two things. The first thing is actually mitigating geohazards, so going out and fixing landslides and managing rockfall and that sort of thing. And then the other thing that I'm sort of focused on is monitoring. So basically producing instruments and using different remote sensing tools to monitor for movement, monitor for rockfall, and that sort of thing. Lately, I've actually been mostly doing business development. So even though I'm an engineer, I don't I don't do a lot of calculations anymore.
Okay, got it. Well, Ben, for the listeners that might not be too familiar with geohazards and the monitoring associated with that and the mitigation, can you walk us through that a little bit and also just let us know how and why is this important for engineering as a whole?
Sure. So when I say geohazards, that covers a broad range of different issues that come up. Most of them are caused by geological features interacting with water or wind or other natural processes to basically cause movement of slopes. That movement most often is in the form of landslides when you're talking about soil slopes and that sort of thing. Very often you see rockfall, excuse me. A lot of people driving down the road, you've seen rocks laying in the road. And that's often caused by freeze thaw and rainfall events, that sort of thing. So geohazards really impact a lot of different parts of our lives. They're not well known, I guess, by the public. Most people out there see them, but there's sort of this hidden danger, if you will, in the background. So when I talk about monitoring and mitigating, basically we do a lot of work with transportation departments. We do a lot of work with private companies to hopefully find those issues before they become a problem for the public, and then in some way mitigate them. So that might include installing soil nails. It might include scaling rock faces to get loose stuff off them, that sort of thing. And my job in the monitoring realm is really focused around keeping people safe. I mean, that's kind of why I got into this in the first place, because I realized about 2 years after getting my undergrad that I could take my geology degree and do something that's actually directly helps people and impacts people.
That's great. No, safety is the reason why a lot of people have gone into engineering and stay in engineering. But I think when you start to talk about, geological hazards, you said it right, and that it's somewhat hidden. A lot of times people don't think about, when they're on the highway and they're alongside a exposed rock outcrop or rock cut, they're not thinking about.
Yeah. Well, there's other hazards too that actually probably the hazard that affects most people directly is expansive and collapsible soils. That's a really common one that you see, especially as developments go sort of further out into the reaches of desirable places to live. You see that a lot. So cracks in foundations and getting water in your basement as a result and that sort of thing. People do see that one a lot, but they often don't think about it before they buy a house. So I like to say I'm a realtor's worst nightmare.
There you go. I said, look at that finished basement. You said, I don't know about that. Yeah. All right, great. Well, you kind of hinted at this a little bit, but talk us through some of the main causes for geological hazards. And of course, each hazard is a different cause, but if you could just walk us through some of them, that'd be helpful.
Yeah. So the biggest triggering cause for most geohazards is water. And that can take the form of, heavy rainfall causing debris flows to happen. So this happens, we've heard a lot, it's been in the news a lot recently with all the wildfires, as those areas get really heavy rainfall events because there's no vegetation to keep the soil stuck to the ground, so to speak. And also the fire itself prevents the water from absorbing. It gathers and creates these big mud flows, essentially, that can devastate communities and are enormously powerful. So it's basically a river of cement, if you want to think of it that way. Another way that water triggers these events is with landslides. As the water absorbs, it increases pore pressure and essentially weakens the slope that, again, during or following heavy rainfall events, you can get landslides to take off, which are a little bit different conceptually. Technically, a debris flow is a landslide, but most people, when they think of landslides, it moves a bit slower, or it might, if it does move quickly, it's kind of an isolated event and the whole soil slope sort of calves off. Another way that water triggers these kinds of events is through freeze-thaw cycles. So you get a crack in a rock, and basically that, when you have freezing, that expands the crack, it expands the crack a little bit. And you see a lot of rock fall in the springtime as things start to melt because the ice in those cracks was actually holding the rock in place. Once it melts, it becomes unbalanced and the rock falls off the slope. So I would say the main cause is water. But there are other events that can trigger things, including earthquakes, any sort of ground shaking, vibrations, even from construction. Those can also loosen slopes and create these sort of geohazard scenarios.
Thank you for that. Water definitely is a culprit, so we have to respect it. We have to know where it is and where it isn't. So at the time of exploration, for any of those early listeners on here, folks early in their career, knowing where the water is on a project site or even historically or locally, that's like super, super important. Super important. Now, you talked a little bit about the geohazard monitoring. What type of benefits does that provide to a community?
The primary benefit is it's twofold. The first one is to be able to detect where things are moving, where there's activity, because a lot of times it's hard to see. And some of the tools we use with remote sensing, like LiDAR, a lot of people have heard of LiDAR. It's really expanded in usage in the last decade or so. Can kind of peer through vegetation, especially in the eastern United States and other areas that have really thick, dense vegetation. It can be very hard to spot a landslide. So monitoring with remote sensing tools and other technologies allows you to detect events. And a lot of times you'll detect a small scale event that's indicative of something bigger that's coming down the road. So that leads to the second benefit where you're able to actually come up with a plan to prevent that event from occurring, or actively go out and evacuate people in some cases, right? So it's kind of a tool for saying, something bad might be coming. Let's prepare ourselves. Let's prepare the community, and whatever that may mean. A lot of times we can go out and fix it, but sometimes it's we have to let nature sort of run its course.
And I'm sure there are numerous types of geospatial data that can be collected, and different types of techniques, different types of ways of interpreting this critical geospatial data in at-risk areas. Talk us through that a little bit.
Sure. There are a million of ways that you can collect data, but some of the ones that are really commonly used in sort of the monitoring and asset management space are, like I mentioned, remote sensing. Remote sensing meaning essentially you're using some kind of sensor, usually a camera of some type, could be a thermal camera, could be a regular RGB visual spectrum camera, or a LiDAR sensor, or even radar, satellite radar, to detect something far away. So it's, when I say remote sensing, there's a lot of things that fall in that bucket, but it essentially means I'm standing far away, or my position of monitoring is far away from whatever it is I'm interested in. Other technologies include, and this sort of falls in remote sensing, but robotic total stations and regular total stations using lasers to measure range of specific points. Inclinometers, so that's an inclinometer, basically just in-ground installation that's telling you how the earth is moving, and you can go out and check these inclinometers manually, or you can set them up with telemetry so they're talking to some data repository far away. Piezometers, you mentioned how important water is. Piezometers measure where the water is, what the water pressure is underground. Those are kind of the main ones when we're talking about geohazards, but there's also other things like small scale extensometers you can use for measuring crack deformation on rock walls and looking at rock fall scenarios. There's an incredible array of sensors, and it's gotten, I would say, the last 20 years, the sophistication of all of our technologies has really gone up, and also everything's gotten smaller and easier to use. So it's, working with cell phones and laptops in a very seamless manner. Used to be there was a lot of manual work involved in gathering the data, less so now.
Got it. And when do you see this instrumentation happening? Especially, is it always tied to a project? Is it tied to somebody seeing something moving and they say we have to instrument? I mean, what are you typically seeing?
Often it's tied to a project. So particularly when you're talking about like commercial development, there are in some cases regulations that require like blast vibration monitoring, for example, if you're excavating a deep foundation in an urban environment, to make sure that you're not, creating new problems for other buildings nearby or other structures. And in other cases, it's more driven by, like you said, someone just discovering an issue and saying, well, this could be an issue that's a big issue. So let's keep an eye on it. We don't think anything bad is going to happen right now, but let's put some instruments in the field and keep an eye on things. And I'll give you an example. So recently Geostabilization was working on a project here where I'm from in South Dakota, where a landslide was impacting a road. Essentially, they had, been managing it by repaving the road multiple times, and then it took off and moved, created a displacement in the roadway, which can be dangerous. So they had us come take a look at it, and we were evaluating the slide, and we were like, wow, this could be a really large slide, and we may not be able to actually stop this thing from moving. So that really affects our engineering recommendations. And in order to decide whether we could actually fix it, we had to put in some instruments and fly some drones and collect a bunch of data. And in fact, it was just yesterday they finished putting in an inclinometer. So that's an example of a scenario where you have to base your engineering decision on, and your recommendations on good information. And that's the main goal of monitoring, is to get that good information so you can make the tough decisions.
That's so important. It's so important. You can have all the information in the world, but if it's not a good information, you can't make informed decisions. You have, data that's saying nothing's moving when something actually is moving, or vice versa. You see something's moving and, the eye, right? And visual things are showing you things aren't moving. So it's like, what do you believe? So that could be a pain. That could be a pain.
Absolutely.
All right, cool. So let's see. For the analysis of natural hazards in real time, I mean, that's very important if you want to make decisions. But how would you say that's allowing you to better understand the risks and preparation of geohazard potentials? What type of things are you seeing these days?
Sure, that's a good question. So there have, particularly with remote monitoring, using radar and LiDAR and those sorts of things, and also with some of the in-ground instrumentation, there's been a lot of work done in the last 30, 40 years on getting that real-time information rolling in and allowing you to predict, to some extent. Predict's a tough word with geohazards, but predict to some extent when your slope might fail, right? When things might go bad. Great example of that is actually, I think it was 2013, the main Fay landslide that happened at the Bingham Canyon mine out in Utah. It's actually, I think, the largest landslide ever recorded. Certainly the largest one that was caused by human activity. They had deployed some real-time radar sensors, and they had a team of engineers basically monitoring that data as it came in, and using something called an inverse velocity theory, where you can hopefully pick out the time of failure. And they were able to do that so accurately in that case that there was very little equipment loss. I mean, there was certainly some that they just couldn't get out of the largest open pit in the world. There was no loss of life, no injuries, everything in terms of keeping people safe, managing, all the infrastructure was basically enabled by collecting that real-time data and using these recently developed theories on how to predict failures.
That's impressive. That's impressive.
Yeah.
What do you think are some of the things that engineers could do to, prioritize the mitigation of geohazards?
The biggest thing that we see is, you gather data, you monitor, you do field assessments. Obviously, just using LiDAR or any other remote sensing tool is not always enough. You're going to have to do field investigations. So make sure you got the right information, you characterize the hazard that you're dealing with, understand how severe, the hazard could be. And then you add on consequences and exposure. So there's kind of a risk equation that's pretty well developed across many different industries and engineering disciplines, where you have some sort of hazard, something that can impact infrastructure or whatever the topic might be. What's the exposure that people might have to that? When we're talking about risk, that's the primary thing, is people, right? Safety. And then if this thing happens, what are the downstream effects? Is it going to take out a bridge? Is it going to go, is a rock going to go flying through somebody's home? So you consider those factors together with the data set, and that allows you to sort of rank your risk, because even a really big landslide, for example, that could take out a road, if that's a rural, unpaved road, and it's only used for forestry access, it's not probably going to be a huge priority, because you don't have a lot of risk to human life or infrastructure. Whereas something much, much smaller in an urban environment could have huge consequences, and there could be people exposed frequently. So you kind of have to run that risk equation, and there are different ways of doing it, but that's the primary way you prioritize.
Excellent, excellent. Well, before we take our break, final piece of advice you'd like to give our younger listeners that are out there?
Listen to and find and listen to mentors. I think that's the biggest thing that has helped me in my career is identifying those individuals who are willing and able to provide you good advice, and keep an open mind. We most engineers are pretty smart folks, and we tend to think we're smarter than some others, and getting out of that headspace and understanding that you are fallible, and there's no engineering project that you don't need a team of people to be successful.
Very good, very good. Mentorship is something we talk about quite a bit on the show, and from experience, I would agree. If you can get on a learning curve if you have mentors, not just one. So thank you so much for that, Ben.
Sure.
All right. Well, we're going to come back in just a minute and close this one out with Ben in our career factor safety end segment. Stick around. All right, welcome back. It's time for our career factor safety end segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Ben Haugen, the Director of Business Development for Remote Sensing at Geostabilization International, or GSI. Ben, you've already had a very successful career. When you look back at your career, what's one thing you've implemented to give yourself a factor of safety in your career?
Maintain connections. Focusing a lot of effort on connecting with other engineers, with people that you respect in the industry, and keeping those connections strong over time. And you can do that at conferences, and you can do that just in your daily work. Because I tell you what, every time I've been looking for a job or interested in changing job roles, the next job I found was because of a connection that I'd had.
It's so important. Ben, thank you so much for that. And thank you for coming on, and thank you for sharing all the great insights with us. You shared some great information and advice I know is going to be helpful for our listeners. If somebody's listening in and wants to reach out to you, what's the best way for them to find you? In social media or an email you want to share?
Yeah, you can find me on LinkedIn, or if you want to just send me an email directly, my email is my first name, Benjamin, Benjamin, .Haugen, Haugen, @gsi.us.
All right, great. We'll make sure to get that in the show notes. So thank you for coming on. This is great.
Yeah, you bet.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 49, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.